In the previous video, we learned how to start a partitioned cache and looked at where you can use it as well as monitor it. In this video, we'll take a look at another cache topology. Before getting started, you ought to download the near cache operation zip file and extract it to your workspace and then import it. After you've successfully imported the project, take a look at the cache configuration file. Under the cache mapping elements, customers is used as the cache name, as we've used previously, and the schema name of this cache is myNear schema. Look at myNear schema under the caching schemas element. As you can see, myNear schemas has two cache layers, the front and back caches. The front cache is a local cache that holds a maximum of 5 objects, whereas the back cache is a distributed cache which holds 100 objects. Another sub-element of near cache is invalidation strategy. It specifies the invalidating and refreshing policy. Let's try the near cache. Before starting, let's look at the cache insert getJava class under the cache package of the near cache project. We'll start this class as a cache server that can insert an object into the cache and retrieve an object from it. It asks what we want to do and performs the requested operation. Click on Run Configuration. Duplicate the partition cache start configuration. Then, update the name as near cache insert get1. Choose the appropriate project name and the main class. Check if JMX is enabled or not. Click on Apply, and then on Run. To create another cache server, back in Run Configurations, duplicate the previous configuration, and update the name to near cache insert get2. Then click on Apply and Run. We now have 2 cache servers and they are ready to perform an operation. Start JRocket Mission Control and check the 2 cache servers. On the left-hand side panel, click on one of the cache insert get classes and start the console. Under the Coherence folder, expand the cache subfolders. As you can see, there are 2 cache servers consisting of 2 front and 2 back cache. The values of all size attributes are 0. Get back to Eclipse and then choose the first cache server. To insert an object, type P and 1. This object is stored in the distributed back cache and not in the front cache. We can confirm this via JRocket Mission Control. We have just one object in the distributed back cache, and it can be stored on either the first or second cache server due to the distributed schema concept. In our example, we added an object to the first cache server, however it was stored on the second cache server. It could be stored in the first cache server too, but that's entirely up to Coherence's discretion. If you look at the front cache of the first cache server, the value of the size attribute is 0. The put operation is directly performed on the back cache when using the near cache topology. Back in Eclipse, take a look at the first cache server. Let's add records whose key values are 2 and 3. Back in JRocket Mission Control, you see that the size of the back cache is 2 plus 1. In Eclipse, choose the second cache server. To get records whose key values are 1 and 2, type in G and enter 1, and then type G again and enter 2. Let's check the coherence attributes in JRocket Mission Control. The total size of the back cache is 3, and as you can see, there are 2 records in the front cache of the second cache server because we retrieved records with key values 1 and 2 from the back cache into the front cache of the second server. If we retrieve the records with key values 1 and 2 again in the second cache, you'll see that the value of the number of hits for the front cache of the second server is 2. Let's try this example. Type in G and enter 1, then type G and enter 2. Then, back in JRocket Mission Control, click on Refresh. You can see here that the hit value of the front cache of the second cache server is 2. We have used the present option as the invalidation strategy, and let's check out how it works. For both cache servers, let's get the record whose key value is 3. Type in G and enter 3 in both cache servers, and you'll see the same record, Marie Atomic, as the result. As you can see, the object with a key value of 3 is present in the front cache of both cache servers. When we update this record from the first cache server by inserting a record with a key value of 3, the updated name and surname is Robert Nielsen. What will happen now when we request the object from the second cache server? Will Coherence display stale data that currently resides in the front cache of the second cache server, or will it get the new one from the back cache? Let's try out this example. Type in G and then enter 3. The name reflected is Robert Nielsen. As you can see, the object with a key value of 3 stored in the front cache of the second cache server is invalidated and refreshed automatically by the back cache. This happens because we have chosen present as the invalidation strategy. Near cache is a hybrid cache and combines the extreme performance of a replicated cache with the extreme scalability of a partitioned cache. In this video, we've seen how to use and monitor it. In the next video, we'll take a look at the implementing storage backing map concept.